Yeah, now please welcome Yvonne on stage from Internet Computer. Please have a round of applause for her, third speaker today. Amazing, thank you. The stage is yours. I hope this time it works a bit smoother, so go for it.
No worries. Welcome, everyone. I'm very excited to be here, and I hope so are you, because today we're going to talk about chain fusion. Now, you wonder, what is chain fusion? But no worries, I'm going to tell you what it is all about. But before we dive in, let me tell you a few words about myself. So, as already mentioned, my name is Yvonne-Anne, and I work at Dfinity, which is the foundation that contributes to the Internet Computer Protocol. And what is the Internet Computer Protocol? That's the protocol behind a general purpose compute platform called the Internet Computer, where the goal is really to run anything on chain. So you can benefit from tamper-proof computation, and to do that for the whole application, not just for some small assets being moved from A to B, but really everything done on chain, including the front end being served in a verifiable manner. Okay, but that's just a bit of background. Now let's talk about chain fusion. Today, when you want to, as a user, no, still back, sorry. Today, as a user, if you want to deal with several blockchains, it's a bit of a pain. You have to remember lots of passwords or keys, and you need to be aware of all the different ways to access them. You may need to install browser extensions or even have apps running locally, and that's not really a nice user experience. It would be much better for the user if there was just one way to access assets that lie on different chains. And with that, we can really use all the potential of the different chains and combine their strength to build applications that really bring a lot of value to the users. Now, how can we do that? And that's what we see on the next slide. We need two main ingredients. On the one hand, a smart contract needs to be able to hold crypto assets and sign transactions. So that means that a smart contract can actually have Bitcoin or Ether or any other cryptocurrency and sign transactions that send these assets somewhere else. And signing is, of course, not enough. In addition, the smart contract needs to be able to communicate with these other chains. And it needs to go in both directions. On the one hand, the smart contract wants to gather information from other chains. For example, how many assets does a certain user has, or at what rate are different assets exchanged, traded. But the smart contract also needs to have the ability to interact actively with the other chains, to send transactions there and trigger actions. And ideally, we can do that without additional trust assumptions. So without having additional players that can interfere, that we need to worry about how they manage their keys, who exactly can sign what, and who is responsible that we get our assets back. So ideally, if we just have the different chains that interact with each other directly without any intermediary. And luckily, to a large extent, we can do that already today. And if you have your smart contracts on the Internet Computer, they can talk to a lot of other chains and sign transactions for them and communicate with them. And in this talk, I tell you a little bit more about how we do that. And on Friday, if you want to see how to really do that in practice and write your own smart contracts that achieve that, then there's a workshop that goes into more details. Okay, but actually, why do we want to bring all these different chains together? And on the next slide, you see that actually we have together, as the whole blockchain ecosystem, we have built a we have now all these silos with a lot of value stored in them, but we want to be able to combine that. And on the next slide, you can see what actually the different chains can bring to each other. So you might have a chain with a lot of liquidity, or you might have a chain where you have a lot of users that are trading some NFTs. And ideally, it doesn't matter on what chain these assets are, but you still have means to actually interact with them and really have all of the interaction on-chain, including the graphical user interface, so what the user actually sees. And that's possible if you use some of the internet computer superpowers. In particular, that you can serve front ends directly from the chain, that you have considerable computational power. So actually, it's no problem today to run a small artificial intelligence model on-chain, to do the inference on-chain and in a really trustworthy way. Then we have already heard in the talk before that you don't want to store everything on-chain. But actually, with the internet computer, you can store a lot of data on-chain. Every smart contract can store 400 gigabytes of data, and that at an affordable price. Then you want to build dApps where you don't have to, or you want to use dApps where you don't have to trust that whoever built it did everything correctly and make sure that it evolves in a good way. But you want to decentralize this power. You want to be able to build contracts where you have voting on how the contracts evolve. And also that is possible with a nice turnkey solution on the internet computer. And last but not least, in the foreseeable future, there will be quite a lot of information that is outside the blockchain ecosystems, that is stored on traditional servers, be them from banks, like their currency exchange rates, or other information like if we remember the talk before, product passport data. So in order to access all this in a smart contract, we want to be able to give this possibility to the smart contracts directly, so they can make calls to these Web2 servers and actually get that data in a trustworthy way, so that the nodes really agree on what they have seen there, and we can make deterministic decisions. And yeah, this is not just something that will happen sometime in the far future, but it's actually happening now. On the next slide, you see that there are just a small selection of the projects that run on the internet computer and use the strength of other chains. For example, we have, there is Bionic, a decentralized marketplace for ordinals. Check it out. They're really very nice ordinals there, and I'm sure everyone needs a couple in their selection. Then you think, okay, great, we may have built a cool EVM smart contract, but actually it's very painful to pay the high gas fees, and it takes still quite some time until the next transaction on Ethereum is finalized. So then there's a solution on the internet computer as well, where you can run your EVM smart contract in a canister on the internet computer and also interact with Bitcoin. There are multi-chain dexes, there are oracles that use the capability of being able to call Web2 servers. So basically, there is a lot of action ongoing on the internet computer right now. Have a look. Now, how is all this possible? We'll see on the next slide. At the lowest level, what here is called integration, you can see how we make it possible for the smart contracts to really interact in a bi-directional way with other blockchains. In particular, we have two ways of doing that. On the one hand, that's something that we implemented from Bitcoin. We have the direct integration, where we have almost light clients running in the internet computer nodes, and they talk to other blockchain, to other Bitcoin nodes directly, fetch their blocks, send these transactions from their smart contracts there, and always, what is very important, they always gather consensus on what they saw on the Bitcoin network. On the other hand, we have a more lightweight integration for EVM, for EVM-based blockchains, be it Ethereum, but also quite a few layer 2s are supported, like Arbitrum, Optimum, Base, if I remember correctly. And there we use the RPC capability that many of them offer. So the internet computer nodes talk to RPC providers and gather information from the networks like that. And again, they form consensus over what they get there. Now that's for the talking to each other, but as I said on the first slide, another very important ingredient is the signing. And if you're not a cryptographer, and I guess that's the case for most of you, then let me tell you a little bit more about that. So basically, every transaction that you send to a blockchain is signed with and if you do it the traditional way, it's signed with your private key, and then anyone that has your public key can verify that it was really signed by you. But if we want to do that with the smart contract framework, then the smart contract, if the smart contract should sign something, then we don't want to store the private key on the actual blockchain network. And for that, we use a threshold signature scheme where the key that is the private key is shared among the nodes in the network, and they need to work together in order to sign, and only if enough of them consider that something should really happen, only then will a valid signature emerge. So this is a very safe way of signing. It also helps silly users like me that may forget their keys or not remember where they stored them, because then it's on the blockchain, and as long as I can interact with the blockchain or with the internet computer and still know how to do that, then my assets are safe. So that's actually something that I'm very, very happy about. So that's the two parts that are important, the signing and the communication. But then I also want to say a few more words about the capabilities that I mentioned earlier that are available to the smart contract. On the one hand, there's the large amount of storage and the compute possibilities that are there. But what is also nice is that as a smart contract, you don't need to be triggered from the outside for some actions to happen, but you can actually set timers. You can say, okay, in 5 minutes, check if something happened on this and this blockchain, or in every 2 minutes, do this and this. And actually, you can do that every second. Then you also have access to non-biased and non-predictable randomness in the smart contract without needing any oracles. And as I said earlier, you can make outcalls to Web2 servers and serve really the whole front end. And then on top, we have the smart contracts. And in addition to the projects that I mentioned before, we also have twins of some of the most important cryptocurrencies. We have twins running on the internet computer for them. For example, CKBTC is a Bitcoin twin where one CKBTC represents one Bitcoin, and you can use it to trade at the internet computer speed. So it takes less than a second for a transaction to finalize. It's much cheaper. You have higher throughput. Yeah, basically it's just much nicer. And the same for Ethereum and a few ERC20 tokens. Now on the next slide, you see a bit how this whole thing evolved. We merged a bit more than 3 years. We launched a bit more than 3 years ago in May 2021, and since then we've been working towards this vision of uniting different chains, first with the Bitcoin integration and the ECDSA signing, then introducing the Bitcoin twin, then earlier this year making the signing more efficient and allowing the RPC connections to EVM chains, and then actually just a few weeks ago we released the possibility to also sign with Schnorr, which opens up a lot more opportunities when interacting with Bitcoin, and also we make more of the information from Bitcoin readily available. And very soon, I don't have a date yet, but very soon we will also extend the capabilities to interact with Solana and sign with yet another signature scheme. The next slide, I will not go into details here, but it demonstrates how you can sign Bitcoin transaction easily here in Rust code. There are lots of examples on our webpage, and like this, you can easily build applications to, for example, inscribe on Bitcoin with smart contracts, or hold BRC20 tokens, build CAs, etc. And yeah, with that, I come to the end of my talk. On the next slide, you see a bit of an advertisement for Thomas, who's giving a workshop tomorrow. For those of you who haven't had enough of Chain Fusion yet, he will really tell you how to build an app that interacts with Ethereum. Yeah, I hope I will see quite a few of you there. And actually, we have a booth downstairs where you can play with our fortune wheel. You can get some of the CK tokens that run on the internet computer but represent assets on other chains, or you can also win some swag or ask us lots of questions. So I hope to see many of you there. And with that, in case you have any questions, I would be very happy to hear them now or any time later. I'm going to be here all day today and tomorrow.
Thanks for the talk. Amazing thing. Anyone, any questions? As mentioned, there's a booth, so if you want to have like long discussions or so, that's maybe better suited, but quick one. Oh, sorry, didn't see you.
Thanks for the talk. Awesome piece of technology, especially from a user's perspective. Seems really cool. A quick question in regards to scaling, and like it seems that the validator set or the people running your nodes would need to then be really, really beefy and then run, you know, integrations, RPCs for whatever have you chain. How do you go about that? How do you, like, does every node then have to run nodes and RPCs for all the chains that you support, and how would you onboard new chains?
So first of all, yes, the nodes that run the Internet Computer Protocol, they are beefy. So don't expect your laptop or your Raspberry Pi to be up to the task. And so, yeah, that's just something we need. On the other hand, thanks to our sharding, we do proper sharding where we really partition the state and the execution. Not every node has to execute everything, and that also means not every node needs to be able to communicate to all the other nodes and all the other blockchains out there, because as you rightly assumed, that would not scale. Regarding the node provider onboarding and etc., I think that would be a bit more of a lengthy discussion, because it is a bit different than in other chains where just anyone can set up a node, because on the internet computer there's actually a vote based on the stake that decides whether new node providers can be onboarded.
Thank you. Another question, or doesn't seem to be the case? So as mentioned, we have the booth downstairs, so if something pops up, just go there.
See you there.
Thanks for your presentation. Here's also beer mug.
Cheers.